Hello dear students, today I will continue the chapter 3D geometry. So questions, exercise 11.3, questions up to 5 we have already completed in the previous class. Now start from question 6. So find the equation of plane that pass through the 3 points. So solution of question 6. First question, just I will give brief discussion and solve the questions. Just you have to write in detail in your copy, homework copy. Okay. So here we know if 3 points are non-collinear, then we can find a unique plane through that, passing through that points. If they are collinear, then there will be infinitely many planes. Okay, so here given points are, first question, given points are 1, 1, minus 1, 6, 4, minus 5, 6, 4, minus 5, and minus 4, minus 2, 3, minus 4, minus 2, 3. These are the 3 points, given points A, B, and C. Suppose we have to find the equation. So first of all, we have to check that they are collinear or non-collinear. 3 points. For checking, it is very simple. Just remember, you have to solve this determinant. Just write the points one by one. 1 minus 1 minus 1 minus 1, 6, 4, minus 5, minus 4, minus 2, 3, and solve it. 1, 12 plus, not minus. So just solve this determinant. Take a determinant, write this point, this point, this point, and you have to solve it. Okay, and check it whether its value is 0 or not. If 0, then collinear points. If non-zero, then non-collinear points. Clear? This is our important formula. So since this is equals to what? 12 minus 10 plus 1, 20 minus 18 plus minus 1 into minus 12 plus 16. This is equals to, here minus 10 means 2 plus 2, here 4 minus 1. This is equals to 0. 4 minus 1, this is equals to 0. Therefore, since determinant is equals to 0, therefore we can write points A, B, C are collinear. Determinant is equals to 0, then points are collinear. Collinear points passing through, plane passing through 3 collinear points may be infinitely points. We know collinear, and plane may be passing infinitely plane, implies there are infinitely many planes passing through given points. That is finish our answer. Okay, we can see also answer 11.3. The points are collinear. There will be infinitely planes passing through the given points. Okay, simple. Now, second pair of points are what? Second pair of points are given also. We can see points are given what? 110, 121, 110. Second, 121 and minus 2, 2, minus 1, minus 2, 2, minus 1. Okay, these are the set points for second questions. Now also check since determinant, this right? 1, 1, 0, 1, 2, 1, 1, 2, 1, minus 2, 2, minus 1. Just solve it. 1, minus 2, plus 1, minus 2, plus 1. 1 minus 2 plus 1. Just solving determinant. And plus 0 into 2 plus 4. This is equals to minus 2 minus 2 minus 4 minus 1 plus 0 minus 5 is not equals to 0. This is not equals to 0. What are the points? 110, 121, minus 2, 2, minus 1. Clear? So determinant equals to what? Minus 4. Here 1 into minus 2 plus 1. This minus 5 is not equals to 0. Okay. Now determinant is equal to not 0 implies points are non-collinear. Okay, determinant, if determinant 0 then collinear. Points are non-collinear. There. The equation of plane is given by, we know what is the formula? Just x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equals to 0. Non-collinear points. If non-collinear points, then just put value here. This is x1, y1, z1, x2, y2, z2, x3, y3, z3. Suppose, and just put the value only. Okay, and x, y, z are the arbitrary points on the plane. Okay, so here x minus x1 means 1, y minus y1 means 1, z minus z1 means 0 equals to, now x2 minus this minus this. So x2 means 1 minus, you can take in any order, x1, y, x2, y2, x3, y3. Okay, so x2 means 1 minus 1, x2 minus x1, y2 minus y1, z2 minus z1. So 2 minus 1 and 1 minus 0, also x3 minus x1, y1. So minus 2 minus 1, 2 minus 1, minus 1, minus 0. Just solve it. You can get equation of plane in Cartesian form involving x, y, z. So solve it. X minus 1, y minus 1, z, here 0, here 1, here 1, here minus 3, here 1, here minus 1. This is equals to 0. Just solve it. This determine what we will get here, just like this. X minus 1 into this into minus 1 plus y minus 1 into this into minus 3 0 plus 0 and plus z into 0 plus 3. 0 plus 3 equals to 0. Okay. This is equals to 0. Clear? Now solve it. Minus 2. So minus 2x plus 2. Here minus 3. Minus 3y plus 3. Here 3z plus 3z equals to 0. Finally, just we can write minus 2x minus 3y plus 3z 2 plus 3 5 plus 5 equals to 0. So this is our solution. Okay, minus 2x minus 3y plus 3z plus 5 equals to 0. So you can get solution 2x plus 3y minus 3z, 2x plus 3y minus 3z minus 5 equals to 0. Okay, so you can write it as plus here minus, that is the solution. This is the equation of plane passing through these three non-collinear points. Okay, this is question 6. Now question 7, find the intercept cut off by the plane. This intercept form, we know question 7, just take question 7. Intercept form, just whenever a plane cut intersects x-axis, y-axis and z-axis, small abc, then we can write intercept form of plane just like what? X by a plus y by b plus z by c equals to 1. So here we have to find the intercepts on x-axis, y-axis and z-axis. That is for us finding small ABC, value of small ABC. Here, question 7, given plane is what? Given plane here 2x plus y minus z equals to 5. 2x plus y minus z equals to 5. 2x plus y minus z equals to 5. This is the given equation of the plane. We have to find intercepts. We know formula just like x by a plus y by b plus z by c is equals to 1. This is the equation of plane. Intercept form. Intercept just like this. Okay, when our plane cut intercept, what? This is a, this is b, this is c. Intercept. ABC. Okay, so just write it in this form. For this, we can write, because right hand side is 1, so you have to make here 1. So 2x plus y minus z equals to 1 upon 5 divided by 5 on both sides. Implies we can write 2x by 5 plus y by 5 minus z by 5 equals to 1. Okay, so here x upon 5 by 2 plus y upon 5 plus z upon minus 5 equals to 1. Just compare it, these two. Comparing with 1. Comparing with 1, we get intercepts on axis as small a equals to 5 by 2, small b equals to 5, small c equals to minus 5. So these are the answer. Okay, you can see what 5 by 2, 5 and minus 5. Clear? Now question 8. Find the equation of the plane with intercepts 3 on the y-axis and the parallel to z-x plane. We have to find the equation of plane. Okay. And intercept 3 in the y-axis. That is here plane is also parallel to ZOX plane. ZOX plane means XOZ plane means what plane? Y equals to 0. So just like this, 8 intercepts on y-axis is 3. Intercepts on the y-axis 3 and parallel to z-axis. Just we are writing like this: x-axis, y-axis, z-axis. This is origin. Now ZOX plane means what? ZOX plane means this plane. This plane. And parallel to, suppose x-axis, y-axis and x-axis, y-axis and z-axis. Then ZOX plane parallel to ZOX plane means ZOX plane, the equation of ZOX plane is y equals to 0. ZOX plane means the value of y is 0 at everywhere on the plane ZOX, and parallel to ZOX plane. If this is ZOX plane, then y equal to 0. Then parallel to this means y equal to some value. And plane cutting intercept ZOX plane means perpendicular, y-axis perpendicular to the ZOX, and plane cutting intercept 3 intercept on y-axis. That is, since the required plane is parallel to ZOX plane, therefore its equation will be of the form what? Y equals to sum, y equals to constant. And here it is given that three. It is given as 3. So equation of plane is y equals to 3. Y equals to 3. Always, because parallel plane. So equation is y equals to 3. Clear? So we can see also answer here. 11.3, question 8. Now question 9. Find the equation of the plane through the intersection of the planes this and passing through the point 2 to 1. Now we have to find the equation of plane which passing through the intersection of two planes. We know if two planes intersect, then intersection is a line. So plane from that line infinite plane may be pass. So we have to find the equation of plane which is passing through the point, a given point. So here given point is 2 to 1 and two planes are given, and we know formula, if two planes are intersecting in line and the plane passing through this line is given by, in vector form we know what, r dot n1 equals to d1 and r dot n2 equals to d2. If these are plane, then passing plane is what, r dot n1 plus lambda into equals to d1 plus lambda d2, while lambda is a constant. This is the equation of plane. Plane passing through intersection of 1 and 2. This is vector form. This is vector form. And also Cartesian form, you know what? Cartesian form. If first plane is a1x plus b1y plus c1z is equals to d1, and another a2x plus b2y plus c2z equals to d2. If this equation first, equation second, this is Cartesian plane. The intersecting plane we can write how? Just take it on left hand side, a1x plus b1y plus c1z minus d1 plus lambda into, also write for equation second, b2y plus c2z minus d2 equals to 0. Lambda is constant. So this is Cartesian. This is Cartesian form. This is plane passing through these two, intersection of these two planes. Also this is vector form. Okay, so question 9. Here question 9, what is given? In the question 9, it is given that two planes. First plane is 3x minus y plus 2z minus 4 equals to 0. Given planes are 3x minus y plus 2z, 3x minus y plus 2z minus 4 equals to 0. First plane 3x minus y plus 2z minus 4 equals to 0, x plus y plus z minus 2 equals to 0. And second is x plus y plus z equals to 2 or minus 2 side, I think. Minus 2 equals to 0. Okay, minus 2 equals to 0. These are the given planes. We have to find the plane passing through the intersection of this. This formula will be used because this is Cartesian form. So required plane. Just I am writing here required plane. You have to write what? The equation of the plane passing through the intersection of plane 1 and 2 is given by just this plus lambda into this is equals to 0, and also this plane pass through the point 2 to 1 given. By using that condition, maybe condition is given in another form. By using that condition, you have to find the value of constant lambda. Then you will get a plane, unique plane. Okay. So required plane is what? 3x minus y plus 2z minus 4, totally left hand side, plus taking right hand side 0 as lambda into this x plus y plus z minus 2 is equals to 0. This is our, just like this. Now we have to find lambda. Since it passed through the point, just you have to write here. Since it passed through the point 2 to 1, it is given in questions. Also, it is given that it will pass through point 2 to 1. 2 to 1? Yes. Therefore, 2 to 1. It will pass through 2 to 1. That means 8 will pass. So, 2 to 1 will satisfy this equation. Therefore, just 2 to 1 x, y, z put here. So, first 3 into 2 minus 2 plus 2 into 1 minus 4 plus lambda into x 2 plus 2 plus 1 minus 2 equals to 0. From here we can get the value of lambda. Okay, this is equation 3. So just find the value of lambda. Lambda is equals to what? Here 3 into 2 6 plus 2 8 minus 2 minus 4, it's 6 means 2 minus 2 upon, just solve it, because lambda this transfer to right hand side minus 2 upon this 2 to cancel 3 minus 2 by 3. So lambda equals to minus 2 by 3 for first question. Okay, minus 2 by 3. Now put lambda equals to minus 2 by 3 in equation third. We get third this. So 3x minus y plus 2z minus 4 plus minus 2 by 3 x plus y plus z minus 2 equals to 0. Now solve it and you can get Cartesian plane. 3 into here, so 9x minus 3y plus 6z minus 12, here minus 2, 2x minus 2y minus 2z plus 4 equals to 0. So just solve it. 9x minus 2x, 7x minus 3y minus 2y minus 5y, 6z minus 2z, 4z, and here minus 12, 4 minus 8 is equals to 0. So this is the equation of 3. Okay, you can see the answer just 7x plus minus 5y plus 4z is minus 8 equals to 0. This is the main answer. Plane passing through the intersection of these 2 points and also passing through the point this. Okay, it is in the terms of Cartesian form. And question 10, find the vector equation of the plane passing through the intersection of these 2 points and passing through the point 2, 1, 3. Same here, just vector form is given. The vector form is given. Just question 10. Or vector form, just I will solve it in very short. We'll just use this formula for 10. Given plane, planes are, what are the plane given? R dot n is equals to d1 in this form. So r dot 2 to minus 3 First r dot 2I plus 2j minus 3k equals to 7. This is equation first in the vector form. First equation. And r dot 2539 r dot 2I plus 5j plus 3k equals to 9. This is second. 253k. And it will pass through the point 213. 213. Pass through this point. Just same. For finding value of lambda, just use the point. Here, this, the required plane will be what? Required plane. We know equation this, just like this. So r dot, here n1 n2, vector n1 is this, vector n2 is this. So we can write just like this. First vector n1, that is this, 2I plus 2j minus 3k plus lambda of n2, this, 2I plus 5j plus 3k n1 plus n2, this, equals to d1 plus lambda, d1 plus, d1 means what? 7. Here 7. 7 plus lambda, d2 9. Just like this. Now we use, this is our plane. So if we can write it, and we have to find the value of lambda. And this plane will pass through the point 213. So just write in, after solving, so here we can write 2 plus 2 lambda, 2 plus 2 lambda into I plus 2 plus 5 lambda into j. Here minus, if we will take plus sign, so minus 3 plus 3 lambda, minus 3 plus 3 lambda into k. So this is, can be written in terms of coefficient of ijk, r, this is equals to 7 plus lambda 9. This is our required plane, and it will pass through 213, that is and its position vector, point P, its position vector is what? OP is equals to what? 2I plus j plus 3k. We know in vector form, for point, just you have to take position vector 2I plus j plus 3, because this point will pass, point will satisfy this equation. So where we write the value of 2, 1 and 3, so just take its position vector OP, it will satisfy this. It will satisfy means in place of r you have to write this. If it will pass through this, that is, and its position vector is this, then just put in place of r 2I plus j plus 3k. This is point will satisfy this equation. So this dot and this 2 plus lambda 2 plus 2 lambda I plus 2 plus 5 lambda j plus minus 3 plus 3 lambda k equals to 7 plus lambda 9. From here we can get dot product just like 2 into this 2 into 2 plus 2 lambda plus 1 into this 1 into 2 plus 5 lambda and 3 into minus 3 plus 3 lambda is equals to 7 pi plus 9 lambda. 9 lambda. Now, solving it, we can find the value of lambda. Here, just solve it. 4 plus 4 lambda plus 2 plus 5 lambda. Here, minus 9 minus plus 9 lambda equals to 7 plus 9 lambda. 9 lambda, 9 lambda cancel, just solve it. Okay, 4 lambda, 4 and 5, 9, 9 lambda plus 9 lambda, because 9 lambda and 9 lambda cancel, and 4 and 5, 9 lambda, 4 into 6, 6 minus 9, minus 3, go to the right hand side, 7 plus 3 equals to 10, so lambda equals to 10 by 9. So here, what is the value of lambda? Lambda equals to 10 by 9. Okay, lambda equal to 10 by 9. So, vector equation we can write by putting, now substitute the value of lambda in 3. Okay. Put lambda equals to 10 by 9 in equation third, we get in this equation. So r dot 2 plus 2 into 10 by 9. Here, this into I plus 2 into 5 into 10 by 9. J plus minus 3 plus 3 into 10 by 9. K is equals to 7 plus 10 by 9 into 9. Okay, so we can solve it and get, just simplify it, you can get result as, first value will be what? Just 38 by this 18 plus 20, 38 by 9i plus 68 by 9j. Here, just 30 minus 27, 3 by 9. 3 by 9, 3 by 90 plus 3 by 9k. This is equals to here 9 cancel, 70. Just you can write r dot 38i plus 68j plus 3k is equals to 7 into 9. 17 into 9, or 17 into 9 equal to 153. 153. So this is our required plane in vector form. R dot n equals to D. Okay. So solution of 10 is this. There is okay. So this is question 10. Now there are 4 questions remaining. Okay. Now question 11. Find the equation of the plane through the line of intersection of plane this and which is perpendicular to the plane x minus y plus z equals to 0. So here the condition is different. Just in the previous questions we already find the plane through the intersection of passing through the line of intersection of two planes in Cartesian form and passing through a point. Here not passing through the plane is perpendicular to the plane in another plane. So here just suppose two planes are like this and on another plane, required plane is passing through this intersection line and this plane is perpendicular to a plane which is given. That means plane is perpendicular to another plane. That means normal to the required plane is perpendicular to the this is plane, required plane. This is perpendicular to another plane. Then its normal and its normal are also perpendicular. So we can find, we can use logic of two normals are perpendicular. That means direction ratios of two normals product sum of product of direction ratios of normals is equals to 0. By using that condition, we can find the value of lambda. So here, question 11. So solution the required plane is given by how? This plus lambda of this is equals to 0. Here from first plane, from second plane we have to write. Okay. So first plane is question 11. Okay. So what is given? X plus y plus z equals to 1 is first plane and 2x plus 3y plus 2, 3, 4 x, y, z equals to 5 is another plane. So x plus y plus z is equals to minus 1, just is equals to 1, that is take from on left hand side. So this is plus lambda of 2x plus 3y plus 2, 3, 4 sorry 2, 3, 4 z minus 5, 2, 3, 4 z minus 5. So this is required plane and this can be written like this. Just combine 1 plus 2 lambda into x and 1 plus 3 lambda equals to y plus 1 plus 4 lambda equals to z minus 1 plus minus 5 lambda equals to 0. Clear? So constant term is this. Now this is our required plane. We have to find the equation of this plane. there is a condition that this plane is perpendicular to the given plane. So its direction ratios of its normal. Direction ratios of its normal are what? X plus b plus cz plus d equals to 0 means ABC are the direction ratios of normal. So here coefficient of x, y and z. 1 plus 2 lambda and 1 plus 3 lambda and 1 plus 4 lambda. These are the direction ratios of normal of its. Also, since 1 is perpendicular to given plane, what? X minus y plus z equals to 0. X minus y plus z is equals to 0. This plane, its normals direction ratios are 1 minus 1 1, 1 minus 1 1, perpendicular, therefore what? This int a1 b1 c1 a2 b2 c2 a1 a2 plus b1 b2 plus c1 c2 equals to 0. So here 1 plus 2 lambda into 1 plus 1 plus 3 lambda into minus 1 plus 1 plus 4 lambda into 1 equals to 0. So solving it, we can find value of lambda and put the value of lambda here, and you can get the equation. So from here lambda 1 plus 1, here 1 minus 1. So 1 cancel, and minus 3 lambda, 2 lambda minus 3 lambda and 4 lambda. 2 4 6, 6 minus 3, 3 lambda. So 3 lambda. Clear? And 1 cancel, and here just 1 plus 1 is equals to 0. Here lambda equals to minus 1 by 3. So lambda equals to minus 1 by 3. Put it in minus 1 by 3. Okay. Substitute this value in 1. Put the value of lambda in 1. We get required plane as just lambda equal to minus 1 by 3 here. 1 plus 2 into minus 1 by 3 x plus 1 plus 3 into minus 1 by 3 y plus 1 plus 4 into minus 1 by 3 z minus 1 minus 5 into minus 1 by 3 equals to 0. Now you can simplify it. So after simplification we can get x minus 1 x minus z plus 2 equals to 0. X minus z plus 2 equals to 0. X minus z plus 2 equals to 0. Here we can see that this we can see 1 minus y term is finished. Okay. Now just simplify. You can see the result. Okay. 11.3 here. What is this? Solution x minus z plus 2 equals to 0. X minus z plus 2 equals to 0. Okay. So this is the solution. Now question 12. 12 can also be solved. Find the angle between the planes whose vector equations are there. Angle between two planes, we know, very simple. Angle between two planes means angle between two planes is given by angle between their normals. So just write normal and you can get solution. Okay. Just here equation of planes are given in which form? Vector form. So planes are given 12. The angle between planes is given by the angle between their norms. So, if theta is angle between planes, then cos theta equals to n1 dot n2 upon mod n1 mod n2. Okay. So here given, what is given? Here r dot, this is equals to, first plane is 5 3 here and 2 2 minus 3, 2 2 minus 3, 2I plus 2j minus 3 k equals to 5. Here 3, 5 3 and 3 minus 3 5, 3I minus 3j plus 5k. Okay, so these are the given plane. Here given planes are this. So here this is n1, this is n1, this is n1, and this is n2. Just use these two vector here and you can get the angle. Implies cos theta equals to n1 means what? 2I plus 2j minus 3k dot n2 3I minus 3j plus 5k upon modulus of this 2a square plus 2a square minus 3a square just plus here 3a square plus minus 3a square plus 5a square. Just solve it. 6 minus 6, 6 and minus 6 and minus 15 upon what? 4 plus 4, 8, 8 or 9, 17, and here 9, 9, 18, 18 and 25, 43. So this is given by, so what is the angle between these two? And also taking modulus sign is there, just modulus sign is taking there. So we can simplify it. 15 by root 731 cos inverse 15 by root 731 theta equals. So this is angle. Clear? So 15 modulus, so plus 15 and this into this 731. This is the required angle. Okay? So very simple. The 13th question. In the following, determine whether the planes are parallel or perpendicular. In case they are neither, not parallel nor perpendicular, then find the angle between them. Just all the planes are given in Cartesian form. We know in Cartesian form, angle between two planes are given by their normal. Okay, angle between their normals. So just one question, 13. First, given planes, there are 5 combinations is there. 7x, 5y, 7, 5, 6 plus 30. 7x, 5y plus 6z plus 30 is equals to 0. First, and 7, 5, 6 plus 30 and 3 minus 1 minus 10. 3 minus 1 minus 10z plus 3x minus y minus 10z, 3x minus y minus 10z plus 4 equals to 0, plus 4 equals to 0. First two planes are there. Now, the direction ratios of normals are what? X plus b plus z plus d equals to 0, ABC. So here A1 7, B1 5, C1 6, A2 3, B2 minus 1, C2 minus 10. Just coefficient. These are the direction ratios of first and second norm of normals. Okay? Now, here we see that. Here we see that. We know if now plane 1, plane 2 are, so this is plane 1, this is plane 2. P1 is perpendicular to P2 if what? A1 A2 plus B1 B2 plus C1 C2 equals to 0, and P1 is parallel to P2 if A1 by A2 B1 by B2 C1 by C2. This is our formula. Now just we have to check whether for this plane this condition is satisfied or this condition is satisfied. So if just for this try, we see that A1 A2 7 into 3, A1 A2 plus B1 B2 plus C1 C2, 7 into 3 plus 5 into minus 1 plus 6 into minus 10 is equals to minus 5 minus 60. This is equals to not 0. This is equals to not 0. Okay? This is equals to not 0, and also A1 by A2 equal to 7 by 3 is not equals to 5 by minus 1 equals to B1 by B2 is not equals to 6 by minus 10 is equals to C1 by C2. That is, both are not satisfied. Implies P1 and means plane 1 and plane 2 are neither parallel nor perpendicular. So we can find the angle between them. If perpendicular, then we say perpendicular. If parallel, then we say parallel. If not, then we have to find the angle between them. And so angle between plane is given by what? Cos theta equals to A1 A2 plus B1 B2 plus C1 C2 upon root over summation A1 square root over summation A2 square. Just solve it and you can find the result. Okay. So here just what? 65. So 65 minus 21 4 minus 44. This is equals to minus 44 equals to not 0. Okay. So minus 44. So here just this is and formula minus 44 upon root over 7 square plus 5 square plus 6 square. 7 square plus 5 square plus 6 square. Also root over 3 minus 1 minus 10. 3 square plus minus 1 square plus minus 10 square. Just solve it. After solving we can get the value. What? Angle between first. Just after solving we get 44 by 110, 2 by 5. Okay. So here we get cos of theta equals to modulus of minus 44 by 110 equals to 44 by 110 cos theta equals to, so theta equals to cos inverse 2 by 5. So this is our angle. Clear? So angle is first angle 10, not 10, 12. Cos inverse 2 by 5. Cos inverse 2 by 5. Cos inverse 2 by 5. So you can get. Just try one by one and you can get result. You may get this, then planes will be perpendicular, 90 degree angle between them. If this, then planes are parallel, means angle between them is 0 degree. So you can decide. Okay, do it in your copy. All the questions, okay, remaining 4 questions. Very simple. Now, last question, 14. Question 14 can be solved also, because 14 are given. In the following case, find the distance of each of the given points from the corresponding given plane. Here, 4 parts are there. Point is given and plane is given. Just you have to find the distance. We know the distance of a point from a plane is given by, in vector form, also we know in Cartesian form. Just like distance of a point from a line in two-dimensional geometry, similar to here, we can find in Cartesian form. So our formula is what? Just one time repeat. Suppose we are given plane r dot n is equals to d. Clear? Then distance from point. Suppose point is A. Position vector having point is A. Distance of A or A having coordinate. Having coordinate. What? A1, x1, y1, z1. This is point Cartesian coordinate. If point having position vector like this in vector form, but plane also can be written ax plus by plus cz is equals to d. This is vector form and this is Cartesian form. Okay, plane. And distance of the point, this is vector, position vector, this is Cartesian form. So distance is given like what? A dot n vector minus d upon modulus of n vector. This is distance. This is our formula. Clear? The vector form. Here Cartesian form is given. The Cartesian form is given. Cartesian form is also what? Just replace x, y, z by x1, y, and z1. So ax1 plus by1 plus cz1 minus, transfer to left hand side, minus d upon root over a square plus b square plus c square. This is our distance formula. Just we have to find the distance by using this. Clear? So just use first. Here 14. First question. What is point? First question, point is origin and 3 minus 4 plus 12. 3x minus 4y plus 12z is equals to 4. This is plane. This is plane. Plus 12z is equals to 3. And point is origin. Point is origin. This is x1, y1, z1. So distance. So distance of A from plane 1 is given by using this formula. What? Modulus of A x1 3 into 0 minus 4 into 0 minus plus 12 into 0 minus 3, just transfer to left hand side, d, upon root over 3, 4, 12, 3 square plus 4 minus 4 square plus 12 square. So this is distance 0, 0, 0, 0, 0 minus 3. Minus 3 upon root over, just you can solve is 9 plus 4. 9 plus 16 plus 1, 4, 4. Okay, this is minus 3 upon 25, 1, 4, 4, 25, 169, root over 169. This is equals to 3 upon 13. So this is distance. 3 upon 13 is distance. 3 upon 13. Clear? So this is distance from origin to the plane. Similar type process, you can find distance of all the points from the given plane. Just you have to write the given plane in terms of ax plus by plus cz equal to d. D is transferred to left hand side and completely put that left hand side with replacing x, y, z by the points and divided by root over sum of square of coefficient of x, y, z and solve it, you can get the result. So do B, C, D, just do from yourself. Okay. And send me solution of some questions for your attendance. Okay. So this is complete of your three-dimensional geometry chapter 11.3 exercise. So there is also miscellaneous exercise, miscellaneous examples. So you have to remember, you have to do all the questions from miscellaneous exercise. And so miscellaneous example, they are very, very important for exam. Okay. So in the next class, I will discuss about some of the questions from miscellaneous exercise. Okay. So send me some solution of questions for your attendance. Okay.